right, this is the motion test review, and this would be the half page that has 8 problems and the answers posted on the bottom of it. The very first problem that we have talks about finding your average speed if you run 50 meters in 10 seconds. So we're going to identify our variables first. This is problem 1. I have 50 meters. Because it's meters, that's going to be a distance. And then I have 10 seconds. Since that's seconds is a time measurement, that's time. And I'm asked to solve for speed. My formula is speed equals distance divided by time. So I plug in what I know, 50 divided by 10. And I could put meters and seconds right here. And then that would be 5. And my units would be meters per second. So when I check your test, I literally look, variables, formula, work, answer, and units. All right. Number 2. A cyclist travels for 30 minutes. Well, 30 minutes is time, so we're going to put 30 minutes here. And they have an average speed of 10 kilometers per hour. Well, here's a problem. Minutes and hours are not the same units, so I'm going to need to convert one. The easier one to convert, in my opinion, would be the minutes, because I know for every 60 minutes, there's 1 hour. So when I do that, 30 divided by 60 is 0.5 of an hour. Now I have hours on both of those. They want to see how far I went, and so that would be a distance. Remember, our formula is S equals D over T. And in algebra, y'all learn dirt, which is D equals ST, or rate times time. It's the same thing. So we have our formula, and we're going to say 10 times 0.5, which is going to give me an answer of 5. Now, unit-wise, this is kilometers per hour, and this is hours. So the hours cancels out, and I end up with kilometers. Okay. Again, I look for that you have variables, formulas, work, answer, and unit. And you could get credit for either one of these formulas as long as you had one of them written. All right, number 3. We have what is the acceleration? So acceleration is immediately what I'm trying to solve for. Of a ball that starts from rest. Well, rest is 0 speed. So I'm going to say it's velocity. Since it's acceleration, it's a velocity problem. And it has a gaining speed to 25 meters per second. And so I have 2 different velocities. Well, the 0 is where I started from, so that's my original. 25 will be my final. And then I have 5 seconds, which is a time value. All right, they want me to solve for acceleration. I have a formula that it's A equals VF minus VO over T on the formula chart. So I'll take 25 minus 0 over 5. Again, this is meters per second on the top, and this is seconds on the bottom. So I'll end up with 5, and the units would be meters per second, or you could say 5 meters per second squared. Either one of those works. Do I have everything I need? Variables, formula, work, answer, and units. Yes, I have all 5 things that I'm looking for. All right, with number 4, on a distant planet, a freely falling object has an acceleration of, so that's my A, equals 20 meters per second squared. What speed will an object dropped from rest? So there's a velocity of 0 meters per second. On a planet acquire after 1.5 seconds. So we have t 1.5 seconds, and we're solving for what speed will it have. So that's going to be our final. So we'll make the 0 our initial. We again have the formula of our A equals VF minus VO over T, but I also have the manipulated formula written down like this for all of you. So you can just do that. So we'll say 0 plus 20 times 1.5. And since this is meters per second squared and this is seconds, this cancels out one of those. And in my calculator, actually I have the answer, should be 30 meters per second. Okay, 20 times 1.5. Yeah. All right. And then I continue and say, what vertical distance will the object cover in 1.8 seconds? So this time I'm going to look for D and I'm going to change the time to 1.8 seconds for this new problem. Let me write it in a different color. We'll do it in white instead. All right. Well, with distance, I know distance, I have the formula VOT plus 1 half AT squared. If that's the case, I have an acceleration, I have an original velocity, and I have a time, and so I can solve. I can say 0 times 1.8, which is 0, plus 1 half times my 20 times 1.8 squared. When you do the math on that, you should get an answer of 22.5 meters because this is meters per second squared. This is seconds squared. So the seconds squared cancels out and you're just left with meters. All right. When I give you all these type of problems, remember that it will be 2 points for variables, a point for this one and a point for this formula, a point for this work, a point for this work, a point for an answer, a point for an answer, point, and a point. So all of these things are worth a point except your variables, which you don't have to list twice. You can just list them in one continuous spot. All right. Let's keep going. We're halfway done. Number 5. Let's see how green looks on here. Oh, green's pretty. We'll write with it. A skydiver jumps from a helicopter, okay, that's hovering. So the helicopter's just sitting there. And they jump out. Whee! Okay, and they're going to fly. All right. So they jump out. So we know their original velocity is 0 meters per second because the helicopter is hovering. If there were no air resistance, how fast would she be falling? So she's falling, which means gravity's involved at 10 meters per second squared. And how fast? So we want to find VF. And we have a time of 12 seconds. So I have to use something that has acceleration and time in it. Well, I have a formula that says VF equals VO plus AT, which I can just write GT because everywhere we have an A, we can substitute it when we're talking about vertical or up-down motion. So VF equals 0 plus 10 times 12, which would mean that she reaches a final velocity of 120. This is meters per second squared. This is seconds. So seconds cancels one of the seconds out and you end up with meters per second as your units. Do I have everything? Variables, formula, work, answer, and units. Yes, we do. Big smileys for all of us all the way around. All right. Number 6. Let's go to yellow this time. Number 6, an ocean's level is rising about 1.5 millimeters per year. Okay. At this rate, how many years? So we're out looking for how many years will the sea level be 3 meters higher than it is now? So we're going to start off with 3 meters. If I know meters is a distance and I have millimeters, so I have to somehow compare that. I have for every 1 meter is 1,000 millimeters. This is not a motion problem. It's a dimensional analysis problem, just to get you thinking again. All right, now if I know that I have 1.5 millimeters for every 1 year, then that allows me to cancel out millimeters, and I'm left with my units of years, just like I want in my answer. So now all I do is multiply across the top, so 3 times 1,000. and divide by the number on the bottom, which is 1.5. And you get that it's going to take 2,000 years before it raises 3 meters. It's a long time. We'll all be dead by then. But, you know. All right, moving on. Number 7. Let's go with white. Mr. Klutz drops his physics book off his high-rise balcony. It hits the ground below 1.5 seconds later. So I have a time. 1.5 seconds. Okay, book. Sitting. False. Ooh, all right. Now, with what speed, so I want a V, does it hit the ground? So I want to know what speed it is down here. Okay, what is its speed up at the top? Well, it's just sitting there, isn't it? So that should be 0 meters per second. So this is going to be my final speed that I want to find. And since it's falling or it's vertical motion, again, we know gravity. And gravity, since it's going downwards, is 10 meters per second squared. All right. So the first part of this answer would be that we want to solve for VF. Ooh, we have really simple equation already manipulated for us, plus GT. I got all that information. I can use that one. So I'll use 0 plus 10 times 1.5, which tells me that it's going to be going 15 meters per second. I don't want to be under that book. That might hurt. All right. And then we also want to find out how high it is. So that we want to find distance. Okay. Well, I can use two different equations, but I already have an equation for distance. That's VOT plus 1/2 GT squared. Now, a lot of people are going to ask, why aren't you picking V equals D over T, Miss C, and just solving for that? And it's because it's vertical motion. Anytime there's vertical motion, I have to keep gravity involved. Okay, gravity has to be in the equations I choose if it's vertical motion. So that's something to remember, okay? So back to solving for my distance. I know 0, I know time of 1.5, I know 1/2, and I know 10 for gravity, and I know 1.5 squared. Okay, well, I can cancel that out because it's times 0. 1.5 squared is 2.25 multiplied by 10 is 22.5 divided by 2 is 11.25. Now, since this was a distance, this will be meters. Okay? Okay, number 8, our final problem of our review. Okay, a rocket traveling at, 40 meters per second. Since it's meters per second, that's going to be a speed or a velocity. You can roughly write a V every time we talk about speed. And sometimes with the problems that we're dealing with, that's what you want to do is just write V all the time. All right, it accelerates at a rate of 2 meters per second squared. Meters per second squared is an acceleration value, so I'm going to identify that as A. Find its speed or velocity when it has traveled 200 meters. 200 meters is a distance because the meters tells you length or distance or height. All right. So 40 meters per second is what we're starting at, so that's my original, and I want to find what the speed is at the end, or the final speed. So I have to find a formula that has A and D and V's and no time. Only one formula with no time. VF squared equals VO squared plus 2AD. All right. VF squared equals 40 squared plus 2 times 2 times 200. Okay, so 40 squared is going to give me 1600 plus 2 times 2 times 200 is 800. All right, 2 times 2 times 200. Okay, 800. Now I have to add those two together. I get 2,400. And a bunch of you are going to say that's your answer because you're going to lose the squared. You can't lose the squared. Because VF is squared, you have to take the square root of both sides. So you have to use your calculator and take the square root. And you should find out when you do that, the VF actually equals 48.99. Since it's a V, V's are meters per second. All right. Hopefully this helps. If for some reason you are confused and need some more help, then come see me in the morning before school or after school. I'm here all the time. All right. Check y'all later. Bye.